Right, so let's have a look at this question on formal proof. Whenever you've got something squared and you could have two quadratic equations and you're showing something greater than, what you're going to try always do is open out the quadratic bit, move all the values onto one side and complete the square. So let's go ahead and do that. So we've got x minus 5 squared minus 6x plus 50. So if we open that out, we get x squared minus 10x plus 25 minus 6x plus 50. That gives us x squared minus 16x plus 75. We complete the square for that. So remember, you half what's in front of the x. Then you minus it squared at 75. You can obviously check it on your calculator. If you put your calculator into polynomial, stick the equation in, keep pressing equals, so go past your x1, x2. It will give you the minimum point of x, which will be this 8, and the minimum point of y, which is 11. Okay, so we've got x minus 8 squared plus 11. Now, what do we know about that? So we know x minus 8 squared has to be greater than or equals number 0, as it's a square number. Therefore, x minus 8 squared plus 11 must be greater than 11. So we know that cos 2x has to be bigger than minus 1 but less than 1. So therefore 11 is always bigger than 1. So this is true. So we can say x minus 8 squared plus 11 is greater than cos 2x for all real values x. Right, so for the second part of this equation, or this question, sorry, you've got some information. And you've got to prove by exhaustion. So whenever you see exhaustion, you've got to try out all the possibilities. So if we take, and we're looking also at the product. So we've got product. So when we see the word product, we're thinking multiply. So we're thinking times. And we're going to say, what are we looking for? So we've got this weird notation. So the z plus means positive integers, so positive whole numbers, and y is all real numbers. Okay, so we've got x plus the modulus of y equals 6. Now remember, x has to be positive integers, so positive whole numbers. So let's think about this. We've got x and y. If x is 1, in order to add up to 6, y has to be 5, but because it's modulus, it could also be minus 5. And then when we multiply them together, 1 times 5 gives you 5, 1 times minus 5 gives you minus 5. If it was 2, this y would have to be plus or minus 4. 4 times 2 is 8. If it was 3, then it would have to be plus or minus 3, so we get plus or minus 9. If it was 4, plus or minus 2, again we get plus or minus 8. If it was 5, we're going to get plus or minus 1, so plus or minus 5. You've got to write out all these combinations. And if it was 6, we'd have 0 and 0. And that's it. We can't do any more because we've only got positive numbers that x can be. And then so we said all the products are between, if you notice, 10 and minus 10. And that's it. So when you're doing proofs, here's another set which you could